Okay, go on.
Mm-hmm.
Oh, this is a basic mistake. No, you can't. No. No, you can't. X is a variable. You can only take constant outside, all right? You cannot put any constant, okay? If you fx here, the only thing you can do is put the constant outside, not as a variable. Yeah. So that is all you can do. C for constant. Try again. Try again. After if you give up, I will help you. You see, we don't have for this one. We don't have much strategy, right? But we know that all of these can be solved by this formula, right? All of them can be solved by this formula. Do you agree? All of them can be solved by this formula. But to apply this formula, we have to rearrange. Okay. Now another way to do it because it's binomial, you can expand that. Would you like to do that or not?
No.
No. Fine. But that's the way to go, right? If you could expand this M series, if you can expand this into the power series, all right? It can be A, B, n minus 1, and plus C, x n minus 2. Okay, you continue until, can you see? So we can integrate them one by one. That is the one way to go, all right? But in this case, as you probably foresee, it's a bit time consuming, right? What else can we do? Can we just do some substitution to simplify this question?
Yes, I think so.
Yeah, you can probably draw your attention and you see the bracket, okay? So whenever you see the bracket, so how can we simplify this bracket in this expression? Yeah, we need something. Yes, that's right. Why not? Yes, okay. If so, how can we organize this integration? Yeah, that's one way to go. Yes. Can we call the integration I? So if you do that, du dx, you found the first derivative, yes. Dx can be solved. Good idea. Yes, dx can be solved. Okay. Good idea. So you can just quote this integral here. Oh, that's a good way to go. Wow, really. Good. Five x. How can you get a 5x? 6x. Oh yeah, 1/6. That's good. Wow. Very nearly. Yes. Now you can apply this trick. You can use this. You can treat it as constant. Okay. You can use this method. That's right. What can you do? Yes, that's good. Yeah, that's right. Yeah. Congratulations. That's right. That's right. You got it. You got it. Can you see?
Yeah.
So basically, when you see this type of thing, you have trial. You can blindly you can just categorically to replace anything in this bracket. All right. So that is one way to go. Okay, so that is how you do it. Can you see that? Yeah. Alternatively, because I just explained to my approach, whenever I saw this expression, right, I count this. Can you see this is the x outside the index is just one less than that one? Can you see? So alternatively, I show you my approach. Okay, alternatively. The result will be the same. So first I just rewrite this integral. Can you see? I put 3x squared plus 4 and put x over here. Can you see? The reason I work here because this one I can simply put the x back into the differentiation. Can you see? So that is one way. This is similar. So this in this way. So we got this. We just copy that 3x squared plus 4 to power 5, right? Then inside, I can write this as x squared, okay, plus a constant. Can we? X. We start from this x1 divided by 2. All right. Can you see that? Yeah. Because these are the same. Can you see dx? So x dx, okay, will equal to dx squared divided by 2. Can you see that? Because these were increased by 1 unit. Can you see that? So this one, after put x inside, became 2. Okay. All right. So next thing is we can put these 2 outside. I can put the 2 outside. Okay. Now because we got x2 here, we got x squared here. What I'm going to do, I just make this happen. So I just copy that one first. x2 plus 4. And this one, I did the 2 has the half has been moved outside, right? But I need the 3 here. I need the 3 here. Can you see? Can you see? I need the 3 here, so I put the 3 here. So then I put the 3 afterwards. We got the 3, that's 6. That's 3x squared plus 4 to power 5. And that became, very interesting happened. That became d 3x squared, all right? Then because if I wouldn't change the result, even I put a constant here. Can you see that? Can you see that? Because d4 were equal to 0. Can you see that? So in this way, I can jump to that variable. That became clear that if I just replace this thing by a variable equal to u, right? So this is just this part. So in this way, the integral will become 1/6. And that is u to power 5. Sorry, it's not, it's 5. U to power 5 and du. So return to your formula. Can you see? You turn to your formula here. Can you see that?
Yeah.
So that is how I do it. But of course, as I say, that you can categorically decide, okay, to replace everything in the bracket, or in the same way to replace. I can give you another example. Similar example. So if you're so another similar example, if you want to work out the integration of say square root 5x squared, okay, minus 1, okay, and this is 4x and dx. So what would you do? This is a very similar integral. What would you do? You can use your choice. Okay, you can use your method. Can we categorically make decision? Do you know what I mean? Can we replace everything in the square root by something else?
Mm-hmm.
Same or similar, not same, similar to the first question. That's right. Yeah, why not? Yeah, why not?
Mm-hmm.
Yeah, then. Okay, can we solve for dx? That's issue. Yes. All right. Substitution, right?
Mm-hmm.
It has become u now. U square root u, yes. Okay, can we simplify this? Yeah, all number, yeah, any number. Oh. Where is the integral sign? Oh, yes, okay. That's right. It's right. You see?
Mm-hmm.
It's it's nearly finished. That's right. Put all numbers in front outside. Okay. What's the integral of this? Oh, not really. Not right. Almost.
It would be times the root.
Yes, that's better. Yes. And probably you miss the constant. Yes. How about the constant? You still have du. We solved that already. Yeah. So you have to choose a proper constant. Oh, it's all right. You can write that. You can.
I think
you can. Yeah. Anything else? Yes, that's right. The reciprocal of this constant. Wow. Well, you are expert now. You're expert now.
Mm-hmm.
Good. Can you see that? Or they just rewrite this? Doesn't matter. You can rewrite this notation for you and afterwards.
Yeah.
Okay, it's your turn. Do you want to choose another question? Oops, wrong. Yeah, you can choose another question from your textbook or past paper. Right. Try sine, cosine. Yes, that's another type of question. Yes, another function to be integrated. So what's your strategy? Sine, cosine. So the basic function, the basic formula we have is this, right?
Mm-hmm.
D sine dx were equal to negative cosine, right?
Yeah.
Cosine x and cosine x dx to sine x. That's all. That's the basic formula. We can apply this formula at a certain stage, but not at the beginning. All right, because they got a power formula. So what is your strategy? Shall we use trigonometry function or shall we use the integration by parts? You can decide. You use a u. Use a yes. Okay. Use 3. Cosine 4, yes. Yes. So we got both sine and cosine now, right? You can simply you can still simplify this a little bit, but sine theta, sine, they still have sine q there. Can you see?
Mm-hmm.
Can you continue? So if you can move forward. So this choice is important, all right? So when you use integration by part, this choice is very important. So we still got a sine x, right? Sine cubic sine.
So I can try again with.
Try another trial, yeah. Sine x. Wow. Yes, we still can see cosine, right? This time. And we cannot get rid of, you see, ideally, we should get something by now. Ideally, we should get something like this, right? But obviously we can't. We still got this factor here. Can you see? So what can we do? So we still got this factor here, which is so we can't go that far. You see? So we cannot go that far. Give up?
Yeah.
You give up. Okay. Okay, I show you my way. All right. This is so I just copy this formula here. So basically you have the exam. You have exams is integration function. Can you see? You got a sine, you got a sine to the power 4. Okay. Yeah. Yet there's also they got a cosine to the power of 3, right? So Q. And so therefore what I do is, because I would borrow this sine, I just borrow a sine x here, can you see? So that would become sine x, right? Sine x multiply cosine x to the power q. And this part became sine x dx. Can you see that? Is that all right? Yeah. Or alternatively, I can borrow cosine. Maybe I borrow the cosine because I convert that into sine. Can you see? Alternative. So this is one way. I say I stop here. I try another trial. So this is trial 2. This time I put the I keep the sine to the power 4. I borrow a cosine here. So this becomes cosine squared. So that is a cosine. That became, this became cosine x dx. Okay, what's the cosine x dx? Can we rewrite that? Cosine x dx. Can we rewrite as a sine x? Can we?
Yes.
A differentiation. So that is a
Negative sine x.
d, positive. Can you follow me? This way. So notice I use when we sometimes in many cases we use a derivative, right? We use a derivative, but in this case I just use a differentiation. Can you see? I just follow the differentiation. Do you agree this is equal, this equation?
Yes.
Because if you just rearrange that, can you see if you just rearrange that, that's cosine x equal to, you divide dx on both sides, and that became d sine x. So which is true? Do you agree? So in other words, the trick is here. I show you this trick here. I borrow a cosine to build this term in order to obtain this one. You see, I got a sine to the power 4x, right? And before that, can we use Pythagoras theorem? Can we use this one? Sine square x, can we?
Yeah.
Okay, and we copy our formula here. That became sine x, all right? Can you continue? Can you see direction to go? I have successfully replaced cosine term by sine term. So what would you do now? Here I have used this entity. This is called the Pythagoras theorem. It's sine square x plus cosine 3x equal to 1. Okay, I use this formula. So when you do a high level integration, you have to beware of all these basic formula. Oh yes, that's right. So in fact, yeah, that's right. You jump to the conclusion, but actually, what you have done is you do use the integration by replacement. Right? Can you see? So I just added some detail here. So basically, what you have done by here is substitution. Can you see? We can just write one more step for you. So net u equal to sine x. Do you agree? So therefore, I will become and u to power 4 multiply 1 take u to power square and then du. All right. From here, get your result. Do you agree? Oh yeah. So you can skip that if you get very familiar with. All right. But for for the sake of communication, better write this down. Otherwise, your teacher will get lost. All right. Done it. Can you see?
Yeah.
Can you see the trick we use here? Although the first one failed, can you see this first trial is trial 1 failed? Can you see? This trial 2 is a success. Okay.
Yeah.
Okay. Let's go to next one. Did you got this from your textbook? Wow, that's a very big challenge now, I think. Another question?
Yeah.
Yeah, that's a definite integral. Cosine square, cosine x, sine x, yes. Dx, okay. Can I add a bracket here? The guy must be have bracket, right?
Mm-hmm.
Okay, go on. How can we solve this one? Cosine square, cosine and sine square. Yeah, perhaps you can use some trigonometry function. Cosine square, sine square. Cosine sine. Yes, do you want to try?
Yeah.
Yeah, you convert them to the cosine. The cubic. Cosine square cubic. Yeah, it's cubic. That's right. One moment, how did you do that? This cubic, where is the cubic go? Where does it cube?
Because this is 2, 1.
Yeah.
So you plus.
No. You can't. So x plus x cube, right? Did you say that equal to x squared? No. That is your formula, not algebra.
Yeah.
There's no formula in algebra, no formula like this. You can, in this case, you can only distribute or expand. And because you have now, so another thing you can if for example if x equal to f1 plus f2, right? So the integration can be written as a sum. So you can use this property. You see, f1x plus f2 dx. You see. So you can have 3 terms. Okay, you have divided this integration into 3 parts. That's one way to go.
I think I know how to do it, but I did it wrong here.
Okay, try again. Cosine square, sine square. Yes, that's the original question. Sine x dx. So yes, how did you get this one? So you just rewrite this part, okay? X, sine equal to sine x multiply x, right?
Yeah.
That is square. That's correct. Okay. That's sine x. That's sine x squared. Yes. You have to be careful. Then you have to be careful. You have to distribute that. Can you see? Better to add up the bracket here. You can only go that far, all right? Because dx must be shared by both terms, right? The dx must be shared by both terms. So this is normally I would put additional bracket here. Oh, so you. Oh, good idea. Yeah. D cosine x, yes. Negative, right? Negative d cosine x. Wow, okay. What can we do?
And then
Sine x is okay. Do we have to use the integration by substitution?
yes, it is.
We have to. Yeah, this part. Okay.
I'm not sure how to do it.
Well, I think you get this is not very simple now, right? Yes, we can look at the original question, right? I give a trial to see. So can we call this integration I? So forget about that sign here. So we just have to, you see, we have considered the strategy here. If I first divide this into two parts, can we put the two outside? That would become cosine square x dx, the first part, right? The second part would be, okay, the simple part is easier. The second part would be sine square x and cosine x dx, all right? And cosine x dx, we know that that's the d sine x, all right?
Yeah.
So the second part is easier. So that if I just rewrite that, the first part is a cosine square x dx, all right? The second part would become the sine square x multiply d sine x. Can you see that? So if we do substitution, then forget about the first one. This first one is a little bit too nuisance. And the second part became clearer. Can you see that if I just replace that, use this integration by substitution, so that will become this easy integral. Can you see the second part? Can you follow me? So you have no trouble with this first part, the second part, right? Now the second part, my observation is that the first part, can you call this is different color? Can we call this as I1? Okay. So the question is, how can we solve this I1 cosine x squared dx? You know what I mean? If we can solve this question, then we can solve the problem. Okay. Yeah, as I can also rewrite the cosine square in this form, so that that will become negative d. Oh, sorry, that's just one now. That can be written as cosine x dx. Can you see? In this way, I can rewrite this as negative. Oh, sorry, positive d sine x. Can I see?
Yeah.
But this is not, this part become uneasy. Okay, see, you have to solve x, because we know that sine square x plus cosine square x equal to 1, all right? So in order to solve the cosine x, we have to use this 1 take sine x square and square root, can you see? Okay, so this part, can you follow me?
Yeah.
If I do this one, with this integral will become different. Can you see? Can we rewrite that one? Can I put the negative sign here? If we use this formula, we solve this cosine x, that will become square root 1 minus sine x dx. Can you see that? Not dx, d sine x. Can you see? We use the previous result. All right. Seems we got the right direction to go. Can we do substitution from here?
Yeah.
We can work out some space for you to do that. Yeah, got some space for you. Yeah. Can we go all the way to up? Yeah. Good. The question is, can we solve this problem? Yes. Good. Okay, I will check if you got, we'll double check your, yes, method is okay. Can we start from here? I have a check. So what I do, I be careful, I just be more careful. I instead of go straight forward, I will just let another variable. So doesn't matter how many times you use integration by part. I can use w equal to 1 minus u. Can you see that? Therefore, I can work out that. So in other words, you can solve the u in terms of w. That's 1 minus w. Can you see? So in this way, du can be rewritten as negative dw. Can you see? Yeah. As a result, I just start from here. This is our I1, all right? I1, I use blue color. I use blue color, this I1, can you see? So in this way, by this substitution, I1 will become simpler. Do you remember this originally, this negative sign here, right? Negative. And then the first part will become square root w now, can you see? And du will become negative dw. Can you see that? Can you follow me? And negative, negative, positive. That became w half dw. Can you see? And then we can follow this idea that become w 3/2, right? By 2 divided by 3. Can you see? My result is different from you by a sign. So next time, be careful, super careful, all right? So you are right, except the sign, okay? Can you follow me?
Oh.
Can you follow me? If I continue, my result is the same as you, except this sign here disappeared. What is W? W is 1 minus U. Can you see why? What is U? Why is sine X? Can you see that? That is 3/2 plus constant or divided by 3. Can you see the difference between my result and your result?
There's just no negative.
Yeah, that's right. So if you want to get a full mark, you have to. Doesn't matter. You see, you can skip, but better just later do. Better use this substitution method again. All right. Wow, it's great. This is a challenging question. No question now? No question?
No, not really.
No, you can, I mean, you can, can you choose another question? Do you think they will ask this type of question during the exam?
I'm not sure. They might.
Because I think they were during examination, unless they specify, you can use any method by all means. Do you agree? Otherwise, they can restrict people's students' problem solving. Trigonometry again, good. Cosine 2x dx. Wow, yes. Okay, what's your ideas? 2x x. This looks simple, right? Looks simple.
Yeah.
Well, we probably can use our previous result. Can you see? This integral is identical to our integral 2. Do you remember? Integral 1 in the previous question. Do you remember?
Which integral is that?
The previous question, in the previous integral is definite. We should substitute the number. You remember the first integral 1 is cosine square x dx. Do you remember? If I go back, can you see? These are integral, which is identical to the question 4 you just written. Can you see this one? Can you see the integral is the same as this question? We don't have to do it again. Can you follow me? This is cosine x, except of course, you see, except this got 2 here. Can you see? The only difference is that here they got 2. You see, this is 2. Okay. Anyway, how can we use the method we just used for the question 3 to solve this problem? Alternatively, you can use some trigonometry formula. When you see the double angle formula, do you know any formula which can rewrite it as a single angle? When you say double angle, mathematics. Do you have any trigonometry formula? Have some formula here. Mathematical formula, yes. If you go to trigonometry, I will check the formula. You can use the formula sheet, right, during exam.
Yeah.
Yes. Okay. I found this formula here for trigonometry. Complex number. Yeah, we should be able to simplify this, but yes. These have, do you know this formula here? This is square. Anyway, so if you, how can we simplify this one? You can try. Oh, yes, that's right. You found this formula now, right? The difference. Oh, good. Okay, you can use this one. Yes.
What do I do when it's cos
if you use this form, if you use a formula, yes, we can get rid of the sign. Can you see? Oh, still we can. You see, you can continue by just rewrite the sine square in term of cosine square. Can you?
But the problem is,
can we first, if you want to keep the cosine, right? Wait a minute, change the sign here. If you want to keep the cosine, and then we can keep this cosine square x, and this will become 1 take cosine square. Can you see? So that will become 2 cosine x minus 1. Can you see? So in this way, can you see? We got identical integral now. Can you see?
Yeah.
We got identical integral. So you can use the formula we just used in the previous question.
What about this though? Because in the formula sheet, it's just cos. Like this doesn't have it.
That's right. Yes, I just show you. Okay, so if you go back, that's how I solve this trouble. This is form. Okay, how do I solve that? Can you see how did I solve that question? I just rewrite this square as cosine multiply cosine. Can you see? And then I group these two together into d sine x. Can you see?
Yeah.
Then we do substitution. We just by this substitution, so we got this form. This is simplified form. Can you see? If I use another substitution w, then we can even got this simple form. Can you see that? This is how we solve this trouble. Because this integral. Can you see that? It's not straightforward, but we can use integration by substitution. Yes, you are right. This formula, there's no direct formula for cosine square. There's no, in your formula sheet, there's no formula for this. All right. So that is why you have used integration. That is why we have used the integration by substitution to solve this problem. Can you follow me?
I think so.
Well, yes. As I just observed, can you see in this in previous question, I noticed that this question. I noticed that this is relatively easy to do. Can you see this part? However, to solve the cosine square, integration of cosine square, then I have demonstrated to you how to use this. Or you use this. You can see. I just rewrite this integral. Can you see? Before I introduce another variable, I first rewrite cosine square into cosine x multiply cosine x multiply dx. That is how eventually I solve this problem. So I rewrite this part. I borrow a cosine x in order to obtain the d sine x. That's how I solve this question. Can you see? So this is dx. The dx is actually obtained by borrowing cosine x, and in order to write the cosine x in term of sine x, then I use this trigonometry identity or trigonometry Pythagorean theory, right? So it's not straightforward to get the cosine square integrated. you have to apply the integration by part. So it's not every function can be integrated directly by simple formula. Do you want to give another trial? Yes, you rewrite that as a product. Yes. How? Oh, you just rewrite. You use your formula, right? Okay. So, yeah, okay. Go on. Yes. Yeah. Oh, maybe you can get something simpler. Maybe yes. Go on. Before you go further, can I put a bracket here? So can you put a bracket here? Wait a moment. You return everything to cosine. Okay. Yeah, you have to be very clear about the bracket you use. All right. Can we just clarify yours writing? So the integral here involves the cosine 2x, right? Cosine 2x squared. So what you did is use the cosine 2x multiply cosine x, okay? Cosine 2x and dx, all right? Now, in order, the second, this time you have to be careful. Then you use the formula, right? They use the formula cosine square x, take sine square x. Be careful. So this part, can you see that? So you have to put the 2 first. Can you see? Cosine 2x. You have used, we need a 2x here. You see? If you rewrite that, so if you put this behind the d, so we have to work out what is the d? What is the d cosine 2x? All right. Cosine 2dx equal to negative sine 2x and 2. Can you see? And dx. Oh, sorry. No, that's what I mean. After integration became sine. Sorry, sine. So we have to check this. So that you have double check that d sine 2x. All right, that can be written as cosine 2x. Okay, d dx, right? And 2 you need the 2 here. Can you see that? So therefore, in order to that, you have to divide, you have multiplied the 2. We need the 2 here, so we need to multiply 2 here, and in the meantime divide by 2. So then you got a half here. Can you follow me? So that will become d sine 2x. All right. Okay, what are you going to do next? I think we stick with the method we use. Do you agree? It's yeah, because it's you see, basically we have solved this question. And see, actually, I show you this quick way to solve this puzzle. I simply can see I rewrite this integral as I just first divided by 2. All right. The reason I divided by 2 because I'm going to use a substitution. So this is 2x, and then I put my 2 here. You see. So in the first place, I have rewrite this one. Then what I do, I use we just let integral u equal to 2x. So therefore, the integral will become half. That is a cosine square u and du. Can you follow me? So these integral are the same. You see, there's no point to come. So these are identical. You can use our previous result to solve this one. Can you see? Here.
Mm-hmm.
Understand?
Yeah.
Solved. Do you agree? Solved. Oops. Wrong. We solved, right? We solved this integral, the question 4. Do you agree?
How do we get the cos out then if this is the u?
Oh, no. You forgot. You probably you didn't. I told you several times. We cannot use formula. In order to solve this question, you have to follow this again. Can you see?
Mm-hmm.
Do you know what I mean?
Yeah.
You cannot use a simple formula because we are encounter the same integral. Can you see?
Mm-hmm.
Do you agree? This is the same integral we encounter now. Can you see?
Yeah.
Same. Because we just got this result here. Why don't we use this result? You see?
Mm-hmm.
We just solve this integral.
Yeah.
So why should we invent another method? We have solved that. Yeah. If you just compare these two integrals are identical, except this use x, this use u, right?
Mm-hmm.
Yeah, we can solve dx. Yeah, we just in the same fashion we have to solve that. That's right. Yeah, you are right. Solve that. Yeah. And then we can introduce another variable. Can you see? If you can introduce another variable, which is can we call w? Can we call w?
Mm-hmm.
You got this w, okay? So the same. If necessary, we can also use another variable v to represent one take w. Can we?
Mm-hmm.
So that integral will become half. That's much simpler. V square root half and negative dv. All right.
Mm-hmm.
Negative half v half dv. Yes, that can be done. Yeah. That is how we use the substitution method. All right.
Mm-hmm. Yeah.
Okay, good luck for your test.
Okay, thank you.
We'll save this.
Mm-hmm.
Okay.
All right. I'll see you next week.
Okay, see you after your test. Okay, goodbye.
Bye.
Goodbye.